Now, I am at frame 1474, and as you can see, we have a bit of a layering problem on top of that wall here. On the screen left side, we have a bunch of smoke, the helicopter itself, and everything going over the plate. Make sure that this has a roto that we're going to use to cut even the shadow pass from the helicopter will need to be fixed. I notice in doing this that we have a bit of a double edge just in this area, so it's worth fixing. So we can go back to changing the gamma value in that grade node, working with the amount of blurring that we're doing here. It helps us kind of bring the connection to a better point here. Okay. So coming back to our wall on the side here, and you can see that this piece of wall is coming into the image. It's not always there. It comes into the image somewhere around 1456. It's the first time we see a little bit of it right there. We would need to ideally have a rotor and use this as a mask to cut everything else that is rendered in Houdini. And the easy way to do that is to have a single shape that we will track, make it follow the shape of the wall and the shape of that rod, and analyze the movement in the plate and apply that movement to that single shape. This way, we don't need to go and animate our shape manually. We can go to a frame where we see the whole wall, maximum visibility on the rod as well. So a good frame for that is 1473. See, the rod is visible in its entirety, 1473, 74. So what I'll do here is create a single roto, a single shape, or maybe two shapes. So I'll create a roto by pressing O on my keyboard. And I'll create a first shape here, which takes care of just this edge of the wall. Here, I'm creating this shape, a typical Bezier curve. So we don't want to create necessarily too many points, but we want to make sure that we take into account the edges, the roundness along the edges. So we can use the tangent. So you can see here, I click and drag, use the tangents to create curvature between the points in order to really follow along the edges right there. So trying to not create too many points. I can always go back and refine the shape later as well. So I'm just going to do some quick closing of that shape here, and then I can go back and refine this. So I can even change the exposure of in the viewer here to better see the edge, to grab really everything that I need to grab. And here you can see I can break the connection by pressing Control on the keyboard, click and drag, and this kind of breaks the tangent. Or if I want to undo this, I select that point and hit Z or Z, and I can reset the tangent. So here I just want to create a bit of a break right there. Here I want to round that off a little bit. Do the same thing here. As you can see, with just a few points, we can really manipulate the shape to our liking. Can create a bit of a break here, bring this here. And by selecting one of the points on the curve, by pressing Z, we can extend or soften that tangent. By pressing Z, we make it longer. By pressing Shift Z, we can reduce the tangent's length. So this doesn't need to be ultra perfect, but it's good to have it sitting really well along the edge so that we can occlude or cut the rest of our renders with the shape very nicely. And here, for example, I have a point that's here. I can simply move it up. If I wanted to add another point to my curve, see, for example, here, I'll press Control-Alt on my keyboard and click on the curve itself, and this will create a new point along the curve. And that should really do the trick for the wall. Now, let's take a look at the second shape that we need to create, which is a bit of a long and thin rectangle. We can do this in many ways. In many ways, we can do this either by pressing, creating points, or we can start with a rectangle. We do something like that, right? And we can select the shape, Control A, bring it into the area that we want. We can zoom in, and now we can take the points, move them about, something like that. See, I'm pressing Control, click and drag around the tangent to give it a bit of a rounded thing. I can grab the last 2 points at the bottom, take them both, bring them into the area that I need, and checking along the line here, along the edge, making sure that my edge is where it needs to be, making sure I'm not grabbing too much of the background, because otherwise we'll be introducing an edge, a bright edge between where we're cutting the helicopter, cutting the smoke, and the edge of that rod. So we have something that actually works fairly well here. We can always go and adjust after the fact, but we'll call this wall roto. And because it's on the left, we'll call it SL for screen left wall roto. Okay, so we have our roto right here. The next thing we want to do is analyze the movement of the plate. So we can use a tracker for that, a simple 2D tracker. And we can start by tracking the plate somewhere around 1473. I mean, ideally, we want to find a point that actually works for the entirety of the frames. The wall is visible. So 1473 is an ideal frame because we see both the wall and the rod. We'll create a tracker node and we will connect this tracker node to our plate. So we'll do it right next to the plate right there. We first need to create a tracker, position it, then analyze the movement of the area that we placed our tracker and let Nuke find the position of this pixel or that group of pixels. So we'll first create a tracker, add track, and we need to find an area of high contrast. So I can find something this kind of black and this kind of darker shadowed area there. I'll just constrain the target zone just to this area. This is the bigger, there we go. The bigger square is the search area. The smaller square is the target. So what that means is inside of this search area, Nuke is going to try to find something that looks like the pixels that are inside of the smaller box. Okay, so what we'll do is we'll track forward from 1473 to the end. So, and for that, we'll go on top here and press forward. And as you can see, at some point, Nuke will stop because it no longer finds that point anymore because it goes out of screen. So that's okay. What we can do when that happens, we can control, click and drag the point here, and we'll try to find another. We don't want to go too far off because we want something that's relatively close to our original search area here. So we'll just go somewhere like that and try to analyze forward again. And it will eventually lose that, but we're almost close to the end, 1497. We only have 3 frames to go. So we can, again, control, click, and drag right here and analyze forward. You can see at 1500, it kind of lost it. So we go back 1 frame. And let's see what happens to this frame. Do we really need to track this again? Well, maybe not. It's just 1 frame left. So what we can do is take that tracker point and essentially manually place it there. It's really the last frame. We try to evaluate how much amplitude of movement there is between the previous frame, the previous frame. You can see here something like that. Keep the momentum going, keep the frame. So that should be fine for frame 1500. Now let's go back to our original tracking frame. So as you can see here, I'm clicking somewhere away from the blue keyframes in here. And then I'll go to the next keyframe here, and that's going to bring me back to 1473. So this time I'm going to be tracking not forward, but backward. We'll click on the play button backward here. And you can see at some point Nuke's going to lose itself. That's fine. All we care about are the points up to the point, all the tracking points all the way to the last visible or usable frame. So what we'll do is we can go to the curve editor or even the dope sheet here. We can find the last usable or the last accurate tracking point, as you can see here. Maybe a little bit hard to see, but if you look at this line here, at frame 1461, it's still correct. It's still kind of following the general trajectory. And the next frame, it's starting to basically go off track. So at frame 1460, it's off. So at frame 1461, it's still correct. So what that means is anything beyond that, I can go and delete. So I'll select these keyframes there. I'll just zoom in a little bit more. So there I can select this in the dope sheet and get rid of them, and even select this keyframe here and get rid of it. And let's go back to our node graph and in our tracker, select our tracker once more. And let's go again to a good frame. So let's say, for example, 1462. This time I will control drag my box to try to find a better area to search, maybe somewhere here, and see what Nuke comes up with. And we will track backward again. And as you can see, it did track for a few frames and then it kind of lost it, but we are almost at the end anyway. So let's go back 1 more frame and control drag this box somewhere here and see if we can add just a few more frames of tracking. So, and then after that, it basically stops becoming precise. So we can just go back to the last frame here. And to be really okay. So because by this time, at 1460, we can just simply manually animate our shape or simply add a few more manually created tracking points to help the tracker complete its task without having to spend, without having to spend too much time trying to find a precise track. So I'll just delete the last good frame, go back to my node graph here, go back to the tracker, select the tracker, and then I can also reset my my search zone here, track reset, sorry, track offset reset, and I can simply continue creating a track if I wanted to, or at this stage, I can just stop the tracking. I can stop applying the tracking and manually go and place and animate my shape. So let's say this tracker is good enough. Make sure you save that. So if you remember, we created our shape on frame. Let's see on which frame it will tell us. Uh, we are on frame here. I'll just go to the next keyframe. There's a tracker. And if we go to the previous keyframe here, we created the shape on 1473. So what this means is that in 1473 in the tracker, we're going to create our transform here set to current frame. That's our reference frame. Our tracker, we can generate a match move node from that tracker. So we're going to go to transform match move baked. Essentially, what this does, it uses the tracking data that you have in the tracker to create a 2D transform node. So it's essentially taking that value, putting it in a transform node, and then we'll apply that transform node to our static shape. So once I have selected that, I'll say create. And Nuke will create a new node, which essentially contains all the transformation inside of that node. And we can then go and apply that to our wall roto. And that means that that shape itself is now going to be animated. So if I view this shape, you can see that it's actually moving around now. I didn't actually keyframe it, but it's actually moving around. Now you'll also notice that the wall roto becomes cut off at the bottom here. And that's because in the roto node itself, we have a clip to format active. So we basically want to say no clip. And if we say no clip, the shape which goes outside of the picture area is still going to remain visible after the tracker is applied or the tracking data is applied to our shape. That's exactly what we wanted. So we want to make sure that by 1460, which is the last frame of our transformation here or our valid tracker, what we want to do is to make sure that we add more keyframes manually this time to make sure that our shape continues to follow our plate. So for that, we'll select the plate, view the plate, and in fact, in order to really see what the result is, we'll simply take this match move, do a merge node A over B. Okay, so we'll put this over the plate. We can change the mix a little bit. It's just for us to see, right? And we can even adjust the plate, adjust the shape a little bit because we have a little bit of a drift between the very first keyframe that we created. You can see it's pretty accurate. But if we go towards the 1460, we see that this shape is sort of drifting off a little bit. So we can go and adjust these points just for this frame, 1460. Bring that out a little bit more. Now, this is maybe not a great way of doing that, moving the points all by themselves. A better way to do that is to select all the points and to move them all along like that. So we will be blurring the shape, so it doesn't matter if we have a little bit of imprecision here. So I can go and adjust just this, for example, just right there. And now we can go a few frames. So let's go to frame, as you can see at 1460, we're okay. And towards frame 1457, we can take this shape and move it. And then finally at frame 1456, we can just leave it outside. Okay. So this is working fairly well. And we can see now that our shape follows the plate, and we'll be using this shape to essentially mask or cut the rest of the stuff. So towards the end of the shot here, we also see that there's a bit of drifting happening. So we'll want to adjust that shape. So go to the last frame, 1500. Just take these points and move them into closer to the wall here, just to make this a little bit more accurate. Something like that. And let's inspect the shape of a different frame, and that seems to work. So our wall roto, again, is going to be used to cut every single render that came out of Houdini, because we got to put this wall as closest to camera, and everything else is further away in depth. So we'll be using this. We'll just add a little bit of a blur here. Let's put it at 4 pixels for now. We can adjust this later. And I will take this roto, I will move it down, and I will then do a merge operation here. The B input is going to be my main input. So Shift X. And the A is going to be my wall roto, which I'll put right here. And in this merge node, I will set this to stencil. Okay. So what this means is that if I have a helicopter going all the way to the edge, now with the stencil is going to be cut out and before it goes on top of the plate here. So we have a nice little sort of you know, cut out shape used there. So and the blur amount, you can of course manipulate how much how much of that softness you want to have. You don't want too much, and you may even need to adjust the shape every now and then. You can see here we're introducing a bit of a darker edge. You can take that and bring it in. So try to not to make too many keyframes, otherwise that edge is going to be what we say boiling. It's going to move around quite a bit. We can adjust it every 20, 30 frames or so, just to make sure that it's actually where it needs to be. So something like that works. And now we've cut out some of our renders or all of our renders with the shape. And we now can look at how to add the film grain to the rest of our computer generated elements so that it's closer in look and feel to what we see in the plate here. We'll also look at how to fix ghosting or bad masking that we see here, pushing and pulling some of these pixels just to make sure that they sit behind the building here so that we don't see these elements being cut by the proxy geo. We want these elements, these CG elements, to be cut out by really the natural softer edges coming from the structure of the building here.